Shall we start, sir?
Right. चलो 3 का ये मेरे 9 का ABCD हो गई 3 का ये 2 का ये 2 का ये रहा तीन नंबर 2 का सी का ये
Welcome you all. I am audible to you, sir.
Yes.
Yes, sir. Shall we start?
Yes.
Yeah. Okay. Welcome you all. The fourth session of this FDP will be taken by Professor Vijay Pratap Singh on the topic of electric vehicle aggregators, a game changer in energy market participation. Professor Vijay Pratap Singh obtained his MTech and PhD degree in electrical engineering from the Motilal Nehru National Institute of Technology, Allahabad. Presently, he is the head of electrical department, Rajkir Engineering College, Sonbhadra. His research interests include robust control application in the load frequency control and power quality in a distributed generation, smart grid technologies, demand response, and energy sources. Professor Singh has published more than 30 papers in the international journal, conferences, and co-author of the computing algorithm with the application in engineering. Please welcome Professor Vijay Pratap Singh. Over to you, sir.
Thank you. Am I audible?
Yes, sir. You are audible.
And my screen is visible?
Sir.
Yes, sir.
Okay.
Yes, also.
Thank you very much. Good evening, one and all present here. First of all,
Yes.
I would like to congratulate the Electrical Engineering Department of MMUT for organizing the Atal FDP on the challenges of autonomous and electric vehicle, which is the recent trend of the research. I would like to give my sincere thanks to the head of department, Professor V.K. Giri sir, the coordinator of this program, Professor Tiwari sir, and Dr. Navdeep Singh for inviting me for this today talk. So my today presentation will be basically on the electric vehicle aggregators. So a game changer in energy market participation. So as we all know that we face the urgent challenges of climate change and transition to the renewable energy. So one of the most exciting innovation on this horizon is the role of electric vehicle. It's not about solution in the transportation sector, but as a powerful player in the energy market. So the today total presentation will be around how the electric vehicle aggregators will empowering the consumers and how it's supporting the energy grid. So now let us start with the introductions. My slide is moving. Slide is moving.
Yes, sir. The slide is moving, sir.
So let us start with the introduction. So as we all know that the role of electric vehicle is an energy system will be crucial over the upcoming years due to the environment friendly nature and ability to mitigate, or we can say it can also absorb the excess power from the renewable energy sources. So significant attention has been given to the EV smart charging solutions by the researchers as well as the industrialists. So as we know that the conventional transportation sector is responsible for nearly 25% of the carbon dioxide emissions, and it's dependent upon the 55% of global oil consumptions. So the main drivers for developing EVs are the energy crisis, the environmental issues, including the global warming and local air pollutions, particularly in the metropolitan cities. So if we see the basic implications of EV includes basically the economic, environmental, and the technical impacts. So if we discuss what is the economic implications of the
Sir, it is not
electric
visible to
vehicle.
me.
Sir,
It is not visible to me.
slide.
Sir, it is
might be
visible.
Might be
It is
connection
visible,
is not.
sir.
Yes, sir. It is visible.
Maybe network issue is there for someone, but it is visible.
Let me check once again. Please confirm that whether the slide
No,
is
no, it is
moving.
visible. It is visible, sir.
Dr. Nadeep, sir, whether I am in slide number 4?
Yes, sir. Yes, sir. It is a electric vehicle which is shown
Okay.
as a leaf on a,
Ecosystem of EVs?
Yes, sir. Yes, sir.
Yes, sir. Yes.
It is
Yes,
moving.
sir. Totally.
Okay, sir. Okay, thank you. So the economic implication is related to basically the power exchange between the electric vehicles and power grid through the V2G technology or G2V technology, which is the vehicle to grid or grid to the vehicle. So basically, both the technologies benefits both the EV owner and the power system by decreasing the share of high-cost generators, such as in the gas turbine in the peak load hours, in order to exchange for the payment to the EV owners. If we talk about what is the environmental impact related to the emissions over an EV lives, so as we know that there is no any flammable gases through the direct tailpipe line emissions of the EV. And if we see the technical aspects, basically it's related to the positive and negative impacts on the power system, which is due to the difference in the spatial characteristics and temporal characteristics of EV charging. So basically, once we talk about the spatial or the temporal characteristics, so basically it refers how their uses patterns vary across the different geographical locations throughout the globe, or if we talk about in our country, and throughout the different times of the day or a week, which is the temporal in nature. So the primarily the influence by factor like the travel patterns, it depends upon the totally on the vehicle owner, how much he is going to drive his car. So it depends upon the travel patterns. Of course, the charging infrastructures availability, whether the charging infrastructure is available or not, and we have the end user behavior. So in spatial distributions, we have to see whether the charging station locations, the placement of charging stations, it's significantly impacts where the EV are charged. Where we can concentrate near the residential area, workplace area, and major transportation hub or in the parking lots. So, and that if we talk about what are the main characteristics of the temporal distribution, so it depends upon the peak charging hour. So as we all know that the most EV charging occurs during the evening hours, actually when people returns from work, and that time they will charge their vehicle, leading to potential grid strain during the peak demand periods. And there is a one temporal distribution is weekend versus weekday patterns. So in which the charging behavior significantly different in weekend and weekday patterns. This is because due to that the higher usage during the leisure activities. Of course, the charging patterns varies with the seasonal variations. So charging demands it may fluctuate based on the seasonal changes like increase driving during the summer vacation periods. So now comes to the what are the electric vehicles? As we all know that it operates an electric motor instead of internal combustion engine, and that's generated by the burning of a mix of fuel and gases. So it could be seen as a possible replacement, and these are the inspired by the ongoing automobile powered by the electricity. Then it is propelled by one electric motor or more using batteries. It's having the instant torque and smooth accelerations. And the main thing is that it's having the maintenance is simpler and cheaper. Then electric vehicle systems ecosystem supports the basically the innovations and adoption of EV by addressing how the EVs are made, how it is used, how it is disposed of. So it also includes the infrastructure need of charging EV. So we should have the charging stations, digital infrastructure, renewable energy. So the key system players is the consumers, how the information is flowing from consumers to the policy makers to the grid. So it's electricity from informations to the where vehicle is charged, whether it is home, whether it is the parking lot area, and all these information should be the bidirectionals. So all the this ecosystem supports the innovation and adoptions of EV for the ecosystems of the EV. So where how the business model will take place, how the EV manufacturers make money, how they are delivering the EVs, how the EVs are sustainable, what are the batteries used, whether we are using lithium-ion battery, lead-acid batteries, in which power we are using to charge the electric vehicle, whether it is the renewable energy power or directly from the grid. So these all are about the ecosystem of EV. So let us discuss about the point of the history of electric vehicles. So already, if we know that, we know that it's began with the long history in Aberdeen, Scotland, through the inventor Robert Davidson. And in 1841, he built a bigger electric train car. And after 40 years of the invention of the Robert Davidson, the inventor Thomas Parker creates the first manufacturing electric automobile in London. And then in 1819, the Iowa William Morrison's was produced first electric car, and that was a little bit electrified wagon, and it's having the 6-seater capacity, having the speed of 40 miles per hour. Why these electric vehicles are important for the society as well as for the ecosystem? So as we, according to the one of survey of Greenpeace research, so the air quality in India is the largest city is it's very deteriorating at an alarming rate. So out of 30 most populated city of the world or in India, and which the 41% of the nitrogen oxide emission in Delhi were due to this only the vehicles in 2020, and the PM is 2.5 emission in Delhi were 23%. So it's more than the permissible limit, more than the permissible limit. So, sorry. So, if we talk about the carbon emissions, so how the due to the advancement of the technological from the internal combustion engines, then in order to reduce the carbon reduction potential, so you can see that in advanced internal combustion engine, it could only reduce 15%. Whereas the natural and biofuels can reduce up to the 30% of the carbon reduction potential. Whether the hybrid fuel plus electric, it reduces around 40%. And if we're having the fully electric and hydrogens, so that could reduce in the range of 50 to 100% the carbon reduction potential having. So. Okay, so due to this a number of deaths due to the pollutions, if we see that India is the largest population density, and here the death occurs more often than any other country due to its geographical and topographical locations of the India, and due to the larger population density. So with the if we see, then it's the pollution due to the pollution is much higher than India, other developing countries or the developed countries. So as per the studies conducted through the statistical analysis, the death due to the pollution is 8 times greater in India. It's around death in millions. It is around 2.5, and if we compare with the neighbor country Pakistan, where death is around 0.31 million, so it's almost 8 times more than death than Pakistan due to the pollution in India. As in compared to the USA, that is developing countries, so it is very more. It is the 17 times something. And as per the Philippines, it's 2 more. So these are the few statistical data which forces us to why we should adopt the EV in our daily life. And the basically major factors that attracts electric vehicles. So why anyone should go for the electric vehicles? So the first one is the reliability and flexibility. So it's electric cars requires lesser maintenances, and as the new model is hitting into the market and offers more flexibility of the car size and style. And the growing infrastructure, we have the facility, we can charge our vehicle at our home. Your car, you can plug your car in right at your home, and more and more area having charging station for where when you are on the go. So actually, it's the once the government is also actually promoting the EVs charging station throughout the country. Even the private players are also they are installing the charging infrastructure throughout the highways and roads in metropolitan cities. And if we talk about the affordability, so it is the of course less expensive and fuel and maintain. And once the government will provide more subsidy, it's the rate will be also reducing. So the cost to buy electric cars are also reducing. Then the one of the important is the public health. So it does not spew the tailpipe pollutions, and due to which that links to the asthma, heart attacks, poor health, and premature death. So these forces, major factors that attracts EVs, and we should use the EVs in our daily life in order to for the environmental benefits. Now comes to the what the electric vehicle aggregators. Earlier we are discussing about what the electric vehicle is, why we choose electric vehicle, and what are the reasons. So now let us start with the what the electric vehicle aggregators. So in power system there are so many type of aggregators. Aggregator is nothing but it is a third party. It's a type of a platform, or you can say it's a type of a middleman which connects electric vehicle owners, drivers, fleet operators with consumers looking for eco-friendly transportation. So in power system, we have the retail aggregators, many more aggregators are in the power system. So the basic aim of aggregator is to earn the profit. So how the aggregator will earn the profit, how aggregator will minimize the charging cost of electric vehicles. So we will see in the next slides. So what is the roles in the ecosystem? So it provides air mobility solutions. Aggregators, they are managing the charging infrastructures. They optimizes fleet operations using data analytics, using AI and IoT-based techniques, and reduces the carbon emissions. So aggregators, basically, it's a consolidated EVs from multiple sources and offer them to consumer through a unified platforms. So one aggregators can handle a number of EVs. So we can make as a cluster of electric vehicles. So the example of other industries in which if you see the Uber and Lyft aggregate private vehicles, they are using for the ride sharing for the passengers. So Airbnb aggregates home for the short-term rentals, and EV aggregators basically optimizes the electric fleet management for efficient transportations. So overall, as we know that the battery charging of EV is mainly accomplished nightly, since daily travel with the vehicles significantly limits the charging time to the night hours. So early night charging of cars actually it puts the negative impact on the power grids characteristics such as the overloading or we can say the fast ramping of the generators. So in addition, the increased penetration of EV may deteriorate the grid characteristics such as feeder congestion. It could be undesirable peak demand. It could be increased power loss. The many more. So what we need that the efficient and smart charging system for electric vehicles. So electric vehicles, this is the one of diagram I have taken from one of the paper. So in which this is the smart charging systems in the power system. So in which the electric vehicle smart charging can recharge EV in decentralized or centralized states. So the connection of EV to a smart home is a type of it's a decentralized charging where you can charge your vehicle, and if you want to charge in the EV located in parking lot, so it is the conducted. So from figure you can see that you can directly aggregators is basically it is a middleman between the transmission system operators. So it's the pricing of electricity based on the electricity markets, the pricing scenario, and aggregator will aggregate all these ancillary services requirement from the feeder. And considering the risks management and optimizations, all the constants, the aggregator will sense the charging or discharging commands to the parking lot area, where we can put where we can charge the electric vehicle, or we can charge our vehicle at our home through the local grid operator, or we can use the renewable energy resources. So this is all about how the electric vehicle smart charging system through the aggregators we can perform. So basically, for this, as you know, for ancillary services, both vehicle to grid and grid to vehicle strategy are needed to enable all the informations we have to enable bidirectional power exchanges. So in the basically, if we see the figure, so it should be the bidirectional. So in vehicle to grid mode, the EV charge to improve the grid characteristics in peak load hours. And wherein grid to vehicle mode, from grid to vehicle mode, it means the EVs are charged to meet the battery energy needs. So whenever the battery energy needs, so we can use the G2V, and whenever the EV charges to improve the grid characteristics, at that time we can use the P2V, V2G mode. So, an EV can be charged through the home, buildings, public parking, charging stations. The charging station, it could be your regular AC charging stations or DC fast charging stations, battery swapping, switching stations, even energy trade amongst the EV. Nowadays, some of the startups are working on providing the energy solutions, charging solutions to the electric vehicles. So the charging points can be energized throughout the utility grid or local energy systems that could accommodate various energy sources. So the EV can charge to the distribution system, the microgrids. It could be charged to the microgrids where energy hubs, or we having the virtual power plants. So what are the role of EV aggregators in a smart charging system? So as we already know that the aggregators are basically it is the middleman, it is the intermediate, and these are basically the profit entities between the power system and end users to enable whether the distributed generations or responsive load to provide electricity services to improve the flexibility of the power grids. So aggregators having both pros can have pros for both the power grid and end user, in addition to their income from energy aggregations. So aggregators are basically responsible for setting up the communication technologies, control devices. So it will manage all the distributed generation resources. They will manage the different kind of loads to provide the ancillary services. They will suggest the consumers that at what time they have to charge their electric vehicles from point of view of aggregators wants to earn more profit, but from the customer point of view, customer wants that he or she should pay lower electricity prices for the charging. So if the load demand is low, at that time the aggregator will suggest to the consumers to charge their batteries or electric vehicles. So we're having the retail aggregators, demand response aggregators, generation aggregators, but in power systems we have the different type of aggregators. So whose objective, all aggregators objective are same. So here EV aggregators is basically, as we have already discussed, it's responsible for power providing, charging, discharge controller of electric vehicles under its contracted area. Their areas is fixed. So basically, it's they manages the battery SOC level of the geographically distributed EVs. So they will actually they manage the battery SOC level. So any aggregators can manage a certain number of PV, and which could be seen as a possible flexible power demands and energy units. So, and EV aggregators try to maximize the profit by conducting the EV charging in low demand hours, and particularly ancillary services market in the high demand hours. So, so basically, the whole purpose is to how to bring benefit to itself and EV owners and the power network. So, what are the role of aggregators in electric vehicle smart charging systems? So, this is one of the schematic of EV aggregators in electric vehicle smart charging systems. So, here you can see this is these are the renewable energy resources, which could be the wind, the PV, and other sources. And another one is the power plants. So we have the power grid operator. So that will decide the pricing signal. And from this grid to the vehicles, the aggregators, this is the bidirectional, and this is the megawatt for the charging station. This is the, in terms of that charging, it will receive some incentive in the terms of money. Here it is mentioned in the dollar, depending upon the SOC level. And if we having this from grid, from parking lot area, charging control of EVs to the aggregators, and once we will fit to the grid, power to the grid. So here again the aggregator will earn the money, and some portion of the money in the forms of the incentive they will provide also the customers or consumers, whatever we can say. So basically, the EV aggregators has two different aim in the wholesale market, and there is two types of market in EV aggregators. One is the wholesale market. So in basically wholesale market, there is a competition between EV aggregators against their demand side market participants for optimal electricity purchase. And another one is there is the retail market, means the client side retail market. So in the client side retail market, the aggregators actually contribute to the end user against the agent which provides similar products and services. So this is basically the role of aggregators in the smart charging of electric vehicle. How the aggregators will play, how will aggregators will take participations in both sides, whether from the vehicle to grid or grid to vehicle. Then if we try to let us understand what the electric vehicle is. So what are the type of EVs? And there are different type of EVs in which their single energy sources are, one of their energy sources is electricity. So we having the battery electric vehicle, having the fully electric. We have the PHVs. It is the combined electric or gasoline engines, hybrid electric vehicles, etc. So these are powered by the rechargeable lithium-ion batteries, often lower operating costs compared to the traditional vehicles. So this is one of the schematic of the different type of vehicles. So you can see that we're having the battery electric vehicles, are so-called electric vehicles, or it is called the totally only electric vehicles or pure electric vehicles, which is fully powered by the battery, having no secondary source, no secondary energy sources. So battery electric vehicle have no emissions. However, the electricity used to charge whatever the electricity we use to charge the battery, they may come from from the fossil fuels, like from the thermal or coal or nuclear. So another type of EV is the hybrid electric vehicle. So it is a fed from both the fuel and as you know, that is from both the battery and secondary sources such as the petrol, gasoline, or diesel. So the HEV, the hybrid electric vehicle, do not having capability of connecting to the power grid for the battery chargings. So in such type of vehicle, the charging of the electric charging of battery is charged through the internal combustion engines. For this reason, the battery in these vehicle is in not a larger capacity. Where is the plug-in hybrid electric vehicles as another type of electric vehicles, which is having the capability. It is the improved version of hybrid electric vehicle. So it's having the two sources, but the one fundamental difference is that its battery capacity size is a little bit more than this hybrid electric vehicles, and this in plug-in hybrid electric vehicles, the battery could be charged through the grid. So basically, it is the improved version of HEV. And another type of electric vehicle is, that is the fuel cell electric vehicles, are so called. This is your hydrogen EV. So, in which the fuel in such vehicle is the hydrogen, and which is the chemical, the hydrogen is converted to electricity through an electrolyte chemical reactions. So, these are the type of vehicles. These are the power and energy density of the fuel cell compared to the other energy storage. So you can see here the fuel cell having the highest energy density. So but it's having the low power density, that is the watt per kg, and energy density is the watt hour per kg. So high energy density means a battery can store a large amount of energy within the given volume or the weight. So here it is weight in per kg. While high power density actually indicates that high power density basically it indicates that the battery can deliver a large burst of power quickly, even if total stored energy might be less compared to the high energy density battery. So the fuel cell, you can see lithium ion, you can see it's having the good energy density as well as here the power density is here. So other energy storage like advanced flywheel, supercapacitors, superconducting magnetic energy storage, then flywheel, conventional flywheel, then all these are the energy density versus the power density. Now how the smart charging, green charging will occurs in in the electric vehicles. Because the charging EV using renewable energy resources are called green charging actually, and these green charging are attracted the attention of the researchers due to the environmental consideration and that in the interest in closure of the fossil-based power plants. So we have to focus. This is we can charge our vehicle at a home. we can charge our vehicle at a parking lot. We can charge our vehicle at the fast charging stations. We having the facility, we can immediately change our empty battery, and we can take it the full battery from the battery swapping station. So a number of battery swapping stations, they are already distributed in the markets by the investors. So, and another one is the energy trade amongst EV. So in this, the power is transferred from one vehicle to another vehicle. So in this, nowadays, these trade actually, I have seen so many startups are working in this area. They have a vehicle which, if suppose if you are going somewhere and you are stuck in between of your way, then there is an option, and if you call on certain numbers provided by the owner, so they will within the 30 minutes or 25 minutes they will reach, and they will charge your electric vehicles through their vehicles within with the help of the fast chargers in 20 to 30 minutes. So nowadays this energy trade amongst EVs is one of the most popular. The research and the trade is going on. Then these are the some charging durations of EV as per the with the help of the DC fast chargers. So comparison to the compact EV, and then a sedan, and this is the hybrid truck. The charging power, if it is 50 kilowatts, and once the charging power is increasing, so it's the charging durations for the 80 capacity of the charging minutes. So it will, if we having the charging power is around 50 kilowatts, so we have approximately 15 minutes, something like that. You can see that SUV sedan will be approximately 23, 24, 25 minutes up to the 80% capacity. It will charge automatically. And if it is a heavy truck, so it will take around 50 minutes, 45 minutes up to the 80% and more than the 60%. Whereas actually due to the low charging cables at a home, generally it took around 5 to 6 hours to complete charge of your with the help of below the 20 kilowatt the charging. And these are the some smart charging objective. The objective should be how to maximize the profit, how to improve the power quality, how to ensure the reliability of the power supply, how to use the share of renewable resources, how to ensure the resiliency, and what the factors affects on the maximizations. And the same way, considering the profit scenario, we have to also ensure that the power losses should be minimum, the voltage deviation should be, it should be constant. There should not be too much variation, plus or minus 5%. On more than that, and the operation cost should be minimum, and the emissions, of course, the CO2 emissions should be minimum as zero as possible. So considering all these things in objective functions, so we have to make the charging of the electric vehicles to make them smart, considering all these constraints in our objective. So in the charging, these are some charging strategy. Actually, for the charging of electric vehicle, 4 types of the strategies are actually performed in the combination of the constant voltage and the constant current. So if we're having the constant voltage, its advantage is that the highest battery lifetime. So what we can do, if we apply the constant voltage on the terminal of the battery, it could draw a current, depends upon the internal impedance and the voltage difference. So if we're having the constant current, so we will get the rapid charging. So constant current is applied in which the charging duration is reduced by applying the larger current. Then we have the combination of constant voltage and constant current. So it is the most simple charging popular strategy, which is the use for the two-wheeler and three-wheeler activities for the electric vehicles. So it is the EVs are firstly charged with the constant current mode up to the threshold SOC level, let's say above the 40%, and then charging mode is changed to the constant voltage for the SOC level beyond 80%. So these are some charging strategies, and these are some ancillary services offered by the electric vehicle to the power grid. So a number of you can get the profit by using the electric vehicle as ancillary services. So frequency response services, you can maintain the frequency of the for power grid, power quality improvement, and the grid loss reductions, you can maintain it. So these are the congestion management or reactive power control. So I will show you some results on how the electric vehicle will take a crucial roles in the frequency response services. So these are some EV penetrated energy system technologies. So we have the energy from the distribution systems to microgrids. We can take from the virtual power plants. So the virtual power plants basically refers to a system that aggregates multiple number of distributed energy resources, like it could be in combination of the rooftop solar, it could be the electric vehicle charger and the home batteries for effective acting as a single large power plant, and we can centrally control all these things. So these are how the EV penetrated amongst the energy systems and how the technologies are there. So we have we're having someone mic is on. So we're having the technologies, chargers and ICT. So we're having the wire chargers, we have the wireless chargers. We can with the wire chargers, we have the charging station AC and DC fast charging stations. And we're having the wireless chargers, which is near the charging stations wirelessly or in the far field. So in near field, we having the inductive wireless charging, then magnetic resonance coupling, permanent magnet coupling, and far field we having the laser chargings and microwave chargings. So these are another area of research. Nowadays, the researchers are doing the research in this area. So in the wireless charging, we having the static charging and dynamic charging, and wire charging, we have the cable charging. So dynamic charging, in a static charging, it is the EV owner should park their vehicle at a charging place and leave it for battery chargings. Where in the wireless charging, it is called dynamic charging. It is called roadway powered online or in motion wireless charging. So the dynamic charging method needs road electrification. So there are some technical and economical challenges to the dynamic charging of EVs for the finite energy transfer distance, stability limit of the power systems, and the high investment cost of infrastructures and reliability and efficiencies issues. There are the major challenges in electric vehicle smart charging is the grid related challenges, the bidirectional power flow challenges, how this flow of power will be managed. Then we having the grid reinforcement challenges, then pricing mechanism challenges, and then battery irrigation challenges, the optimal location of charging station, then battery swapping challenges. A lot of challenges occurs, and what we have to do, we have to overcome all these challenges in order to get from the customer point of view, in order to get the maximum profit, and how we will support the grid from the aggregator point of view. So these are the major challenges in electric vehicle smart charging systems, in which the research are going on. So then there should be the pricing mechanism challenges, the grid reinforcement challenges, etc. Nowadays, the potential target of the cyber attacks. Recently, I have this figure I have in one of the reference paper, in which earlier we are saying that the Ukraine attack and the spring attack in Italy. So there was some ransom attack on the power system in order to disturb the power supply. So nowadays, researchers are working in the field of power system. They are trying to make the defense and mitigation strategies for the power system. So, in perspective of the attacker mindsets. So here, how the attackers will basically actually attackers will attacks on the electric vehicles. So basically, in this, attackers will actually attack on it is the SOC level of your battery, and it will give wrong informations to the aggregators. So that is, let us suppose that your battery SOC level is below 40%, and once if attacker attacks on your SOC level, and if the attacker sends a command to the charging stations, and that the SOC levels of the battery is full, so immediately the charging station will stop the charging to the batteries. But thing is that in actual side, the battery is only charging 40%. So you may stuck in between the ways. You will think that my battery is on full, but in actual condition, you have charged your battery up to the only 50% or less than 50%. So the attackers targets now nowadays a recent trend of research is covering on this electric vehicle smart charging in attacker perspective. So basically their focus on will be the battery management system, and their will focus will be on board charger. They can attack on the charging components supplier network through the ICT. So what we have to do, we have to also be make sure that we do not have any unavoidable or this type of attacks. So for that, we have to make our strategy in a such a way that the effect of these type of attack is, it is mitigated. So what are the importance of EV aggregations? So this is the energy markets or the system operators, where can we have the n number of EV aggregators, and each EV aggregators can having the n number of the clusters. So there will be a communication line between the EV aggregators and the EVs, and these communications signals or informations will be in, it is in the bidirectionals. So it's supports clean energy adoptions. It reduces the dependency on the fossil fuels, enhances the urban mobility. It's a lower operational cost for the business. So basically, it's bridge the gap between the vehicle supply and consumer demand, ensuring efficient utilizations of resources. These are the current market trends. The key trends is the expansion of EV charging networks, and that could be only possible through the once the government will take interest on that, and government is in their policy on FAME 9 in 2020, they have set a target to more than to build 10,000 charging stations, whereas the private players like Tata, Mahindra, even Maruti's, they are going to expand the EV charging networks throughout the country. So, of course, the government incentive promoting the EV uses, the corporate fleet transitions to electric vehicles. So these are the current market trends. So the EV market growth and adoption. So if we see the what the main factors driving EV adoption, so basically the declining battery costs making EVs more affordable, government subsidies and tax incentives, expansion of the charging infrastructure. So the main concern with the EVs, the main dilemma with the EVs in the mind of the consumer is with its long range. With the short range. So if we're having the sufficient number of the charging infrastructure throughout the highways, we need not to the worry. We can go anywhere through our electric vehicle. So, and another one is that awareness about its sustainability. So the government is also trying to promoting the awareness amongst consumers regarding to its sustainability. And China and Europe and US are the leading in EV adoptions with the projected 50% market share by the 2030. But India will also, it's in the developing country, and up to 2030 we will having on third positions or fourth something in the adoption of the EV. The main challenges in the EV adoptions, why the customers are not adopting the EVs. So the first one is the limited charging stations. So that of course leading to the range anxiety, and it's take longer refueling times compared to the gasoline vehicles. So battery degradation over the time. So addressing these challenges through policy supports and technological advancement, one is a key to the widespread EV adoptions. Then how the revenue generations for the EV aggregators. So it could include the charging infrastructure integration and revenue sharing models, fleet leasing and corporate partnership, ride hailing and subscription-based mobility services. And if we leveraging the smart technologies with the help of the smart algorithm data analytics, and the EV aggregators can maximize revenue opportunities. These are the some technologies in EV aggregations. We have mobile app, AI-driven, IoT, and blockchain-based. So, and the integration of these technology basically enhance the efficiency and improves the user experience. Then challenges we have already discussed in EV aggregations. So initially high investment in EV procurement. And nowadays there is a dependency on the government policy and incentive. Need for the robust charging and fast infrastructure should be there. And consumer hesitation due to the limited awareness. We have already discussed all these challenges. And what is the future of EV aggregations? So it's include the expansion of fully autonomous electric fleet, battery technologies for longer range and faster charging. So recently, as you know that the Nexon has, the Nexa, Maruti company. So it's going to build the EV car with the range of 650 kilometers with the 60 kilowatt hour battery pack. And they will install their charging station at the dealerships locations throughout the country. So integration with renewable energy sources like solar and wind is a crucial role in achieving a sustainable and eco-friendly mobility ecosystems. So summary of key points that EV aggregators are transforming urban mobility with the sustainable solutions. The market is growing, as you know, due to the increasing EV adoption and supporting policies. A billion number of the electric vehicles will be in the market up to the 2030. So technological infrastructures and business model are crucial for success, and overcoming challenges will unblock immense growth potential for EV aggregators. So these all are about the EV aggregators. It's the challenges, how we can go for the smart charging system, what are the barriers with EV aggregators in the real-time market, and how the EV aggregators is the game changer in energy market. Okay, so this is all about from my sides. But I think it's if you have any query, you can ask. Otherwise,
Thank you, sir, for your remarkable lecture. May I request to participant, please ask any query if you have. Sir, one query in the chat box.
just 1 minute. Let me open my. Actually, I have right now. I have opened my PPT mode. Just yes, ma'am. You can ask.
Yes, sir. Sir, one question in the chat box asked that can we use Venn diagram for generator for EV charging?
One day graph for generator for EV charging.
Yes, sir.
Actually, I'm not
Common
aware of
sense.
what the one day graph is there. One day graph generator for EV charging. So I have to look at what the one day graph for EV charging actually it is.
Okay, sir. Any further queries? Participant? Anyone have a queries? You may ask.
Sir,
Yes.
sir, do we have any such information about companies which are planning of this aggregation part, specifically when they are installing these charging stations? So, are they capable of feeding power back to grid?
Actually, it is the companies. If we talk about there are the many top of the charging solution providers in India, which is the Delta Electronics, one of the company. It is situated in your Delhi. So and Mumbai. So they have launched. I think that is the first DC fast charger in Maharashtra, something the place. So basically, they have the partnership with the MG Motors and EV Motors, so enable the EV charging infrastructures. So actually, once we having the sufficient number of the electric vehicles in a parking lot area, and then it could be fed to the grid if it is during the peak load demand periods. So there are so many companies in India, as then I think in Gujarat, one is the Ahmedabad transport services. I think it's providing a 150 kilowatt DC fast chargers. So there are the several companies which are working in India, and their aim is to actually to build a fast charging station throughout the company. But main issue is that once we have the sufficient number of EVs in the parking lot area, and we have the mechanism, then we can go for it.
Thank you, sir. Sir, there is one more question in chat from the Divakar Singh. This is Scholar of Development. He has asked that what are the causes are affecting the HEV growth in India?
Causes of
HEV growth in India. What is the cause of affecting HEV growth in India?
Of HEV growth in India. What are the causes of affecting hybrid electric vehicle growth in India? I have HEV, that is the hybrid electric vehicles. So the main reason with the HEV, with that it's having the two types. So it depending upon two types fuel, and that is the one is the battery. It's having the smaller battery, and this smaller batteries are it is charged through the internal combustion engine, and it do not have an capacity. It do not having some charging strategy, so we cannot charge it through the power grid. It's the battery capacity is small, and these are the hybrid cars which cost is actually it is too much than the actually the pure electric vehicles. So I think these are the main factors, and that's all from my side.
Okay, sir. Sir, there's one more question from the Jansandeep Singh, that he asked that what are the cost of setting up charging setup by individual?
Actually, it depends upon how much we are going to build the fast charging stations. Okay, so the cost of setup of electric vehicle charging in India or by in any individual, it depends upon the several factors. I think it depends upon the locations, it depends upon the equipments and the additional features. So that will depends upon the which type of the chargers you are going to use. You have to do the lot of civil works in order to build the charging infrastructures. If your land is not yours, so that you have to purchase your land, or you can take it on lease also. So nowadays for the lease of the land agreement is almost, it is in it is the more than lakh rupees, and then you have to electrify that charging infrastructures. You need to be the transformer connections, energy meters. Then you must having the technical team, and then for the smart charging infrastructure management software. So almost it's a not a small deal, it's a big deal. I think the exact price depending upon the how much kilowatt of the fast chargers you are going to install. So let us if we covering all these things, so that will around more than around 50 lakhs and something. So but it will be totally depend upon that what type of the charging the fast charger you are going to install. So the exact amount I do not have an exact amount figure, but the covering all these figures considering the infrastructure, land, transformer, everything, is more than 50 lakhs, something on that.
Thank you, sir. Sir, there's a question from Vinay side. He asked, any difference if we use solar power EV comparison?
If we use solar powered EV, comparison means I think solar power EV is more cost effective and environment friendly, because actually if we see, then if we have to charge the EV, if we do not, we are charging our EV through, the some conventional power plant through the energy from the, from the grid directly. So, of course, it could be more using solar power, it could be more cost effective, environment friendly. And it depends upon the charging cost. Solar power charging station are often cheaper, than grid power station. The reason being is very simple. Everyone knows that the solar electricity is cheaper. And if we talk about to install the solar panel at our home, so initial investment in the solar panel can be expensive. But the nowadays government are providing the Pradhan Mantri Surya Ghar Muft Bijli Yojana. So depending upon the kilowatt, the central government are giving the subsidy. Let us, for example, for 1 kilowatt, the central government is giving subsidy of around 30,000, and then state government is also giving the subsidy around 15,000. So for 1 kilowatt installing solar power panel, the total subsidy get by the customer is around 45,000, and the cost decided by the government is around 60,000. So anyone can install the solar panels, 1 kilowatt solar panel, by paying 15,000 rupees only. So so it's not about initial investment, not about too much initial investment. And if we discuss about the carbon footprint, the charging EV with solar power, if we are charging our EV with the solar power, that will reduces the amount of electricity generated from the fossil fuels, and clean electricity. Solar panels generate cleaner electricity. So these are the some differences. Many other differences, free charging you can see, or and another difference is that in night we do not have an such type. We do not have solar can have limitations. We cannot charge our vehicles with the help of solar in a night. So these are the some. The comparisons are there. We can consider it all.
Thank you, sir. Thank you. Any other queries from participant side? I think there is no more query. Thank you, sir, for clearing all the questions and for the great lecture on this topic. Thank you, sir.
Thank you everyone for your patience and listening me. Thank you.
Thank you so much.
Thank you, sir.
Thank you.
Thank you, everyone. Next session 5 will be started tomorrow at same time 6 p.m. So you can leave now. And attendance sheet and feedback is also given in a chat box. So carefully fill it day to day wise. Thank you and good night.
Thank you, sir. Good night, everyone. You may leave now. Everyone, can you leave the session now?
you.